Hello and welcome to our next lesson in our chapter 7, for similar figures, or similar polygons. We are working now in 7.3. The last lesson was on similar polygons, 7.2, and now we're actually going straight into triangles, similar triangles. So if you remember in the last class, we talked a lot about proportions and scale factor. And there is a scale factor that's used to calculate sides that are similar in any given polygon. This class is going to revolve solely on triangles, and there are 3 ways to prove triangles are actually similar. So if I gave you just 3 triangles just off of the bat, and I gave you certain pieces to them, and this is a terrible second triangle, so let's just copy this. Copy, paste. As of this moment, these are congruent triangles because they could lay them directly on top of each other and they would line up perfectly. All the sides would be congruent, but then once we make this larger or smaller, they become similar. And it becomes a question if you have 2 triangles that are not the same size, how can you prove that these triangles are in fact similar? And we talked about the first way to do it in the last lesson is if all of when you have similar figures or similar triangles, all of the angles are congruent. So that is actually the first of the 3 ways to prove triangles are congruent. So we're actually going to write 3 ways, and I'm going to keep these triangles up here as a reference. Actually, no, let's do this. I'm going to bring these down. I'm going to bring these down for the first example. So sorry if you already started drawing that. Let's shift this up here, right about there, so we should be fine. 3 ways to prove triangles are similar. And the first way, like I said, was from the last section, is that if all the angles are congruent to each other, then they are similar. So, ironically enough here, I'm going to put this in pink. If I gave you a triangle that was 50, 60, and 70, 50, 60, and 70, these 2 triangles would for sure be congruent because they have all the same angle measures. And it doesn't matter what order you actually put them in. You could put a 70 here and then the 60 here. The fact that they still line up with another angle or correspond to another angle properly proves that they are similar. And in fact, you actually don't need you don't need 3 angles to be given. For instance, if I took away one of the angles that are, and we still have 2 angles that are congruent, it should be assumed that this last piece that's missing, x, can be solved for because it's a triangle. Do the math. These add up to 110. Meaning the last angle has to be 70 degrees in order for us to complete a proper triangle. And it should be assumed that if you have 2 congruent angles in a triangle, then the third one is also congruent. And we actually only need 2 angles to solve similarity. So remember, this means similar, in case you forgot. And we're going to say this is the angle postulate. Now, don't get this confused with proving congruency. We have 4 ways to prove congruency: side, 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 angle, and angle, side. Okay? That was to prove congruency. This is to prove similarity. So angle, if you want to put this as a side note, you are more than welcome to. Angle is a way to prove congruency. So I'm going to put a 1 next to this. And we're going to actually go ahead and state it out. If 2 angles in one triangle are congruent to 2 angles in another triangle, then the triangles are similar. So that is our first method, our first way to prove similarity, okay? And that's exactly what I showed below. Second way should actually sound familiar. And this is going to be the side, 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 but with similarity. So side, side, side also shows up, just like how it did before. So side, side, side. And what we're going to do is we actually don't prove that they are congruent to each other, even though that works, but we're going to prove that they are proportional to each other. So I'm going to draw another set of triangles. Ooh, that's not a triangle. And I'm going to once again copy this. I'm going to paste it. I'm going to make this a little bit larger. I'm going to shift this down so I have a little bit of room to work with. And for instance, if I said we had a length of 2, 3, and 4, and let's say this is cat and dog. And then on the second triangle, we had all 3 pieces. If you notice that this is, we call this side, side, side because all 3 sides are given. In order for it to be proven properly here, we need to show that all 3 sides here are given, or they should all be given. So if this was, let's say, let's do something simple, 4, 6, and 8. All 3 sides are given in the second triangle as well. Can we prove proportionality in all cases? So if we take a look, and personally I would take a look at the corresponding parts, and I would also, reorder them in terms of smallest to largest, because that's how it would be proportional. 2 and 4 are the smallest pieces. 3 and 6 are the medium pieces. 4 and 8 are the largest pieces. So that's a proportionality you're probably going to want to check. And if you do this, for instance, CA has a length of 2. So you actually don't have to write CA if you don't want to. And then its corresponding part would be 4. That is our scale factor from 2 to 4. If that scale factor is the same across the board, for instance, from 3 to 6, 3 to 6, if these all end up being congruent to each other, then we have proportionality. And then CT, which is the largest side, is 4. DG is 8. And if you notice, they all reduce. They all reduce to the same value. 1/2, 1/2, 1/2. So they all have the same scale factor of proportionality, thus proving these 2 triangles are in fact similar. Okay? So, these 3 have all sides are proportional. Ooh, I forgot to mention this. If you have all 3 sides that are proportional, then we could say triangle CAT is similar to triangle DOG. And I actually did not mention that up above. Let's come up with another one. Ant and pig. And we would here say triangle PANT is similar to triangle PIG, and making sure we're lining up the corresponding, it shouldn't be a PIG in this one actually, PGI, because I changed this around. PGI by angle, similarity. And this one should be by side, 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 similarity. Okay? So let's write this actual if-then down. If 3 corresponding side lengths of 2 triangles are proportional, then the triangles are similar. Okay? And then the last way to prove is if you have two triangles. I'm going to take this, copy it again. Let's blow this up a little bit. I'm going to shift this down slightly. And let's use hog. And let us, I don't know, another animal with 3 letters. So let's just do cat again, I guess. Let's go just go cat. Okay. And this postulate says that if we have one side that is proportional to another, actually 2 sides, I should say, 2 sides that are proportional to 2 sides in a second triangle, and the angle between them, the shared angle, is also congruent, we have similarity. So, taking a look at this actually looks like one of our old postulates, side, angle, side, and it is, except this is for similarity. So we have side, angle, side, similarity, which states if 2 corresponding sides, notice this is 2, not 3, like in the last example, 2 corresponding side lengths are proportional, of 2 triangles are proportional, and the shared or included side, and put shared above it, and shared angle, I should say, are congruent, then the triangles are similar. So, if I gave you, for instance, a length here, 2 and 6, this length HG, let's call this 5 and 15, we would have to, and then let's give a length, let's say 30 degrees and 30 degrees. First thing we need to check, are the 2 sides proportional to each other? So looking at it, 2 and 6 should be corresponding, 5 and 15 are corresponding in terms of like which one's smaller, which one's bigger. So we could say 2 over 6, and then we could also say, is that going to be some to have the same scale factor with 5 over 15? Well, 2 over 6 reduces to 1 over 3. 5 over 15 does the same. 1 over 3. So these are, in fact, congruent to each other. So these are proportional. And then angle H, is it congruent to angle C? Which it is. And it is the shared angle. Okay? So we could then say triangle HOG, and we started at the angle measure, went through the 2, is similar to triangle CAT, because we did the same thing. Started at 30, went through the smaller side, by SAS similarity. Okay? All right. If you have any questions on any of these are the 3 ways to prove triangles are similar. And I'm going to put it here. Let me finish this out. Side, angle, side. These are the 3 ways. And we have 2 of them cross over. And you could argue that this one is kind of similar. Angle, angle, side is very similar to angle, angle. But it is and it's not. Okay. So I would leave it at that. If you have any questions, please ask, and I'll see you in the next one. Bye.